All right, time is 12 p.m. everybody, so I think we can go ahead and start. Good afternoon, everybody, and happy Thursday, and welcome to today's webinar called the Refactoring Test Code. And before we get started with the content today, I'd like to go over a few notes again on how to participate on today's session. As usual, the duration of the session will be 1 hour. The speaker will be presenting 40 to 45 minutes, followed by the Q&A session for 15 to 20 minutes. And if you have any questions to our speaker, we ask you to please address it through the chat and anytime during the presentation, or wait till the Q&A session at the end of the presentation, and our speaker will try to answer as many questions he can during this event. Also, I'd like to remind everyone that today's presentation will be recorded, and we'll be posting all the recordings to our YouTube channel. And for those who couldn't join the call, or anyone who wants to rewatch the session and make notes from the presentation, you can do so in our YouTube channel. I'll also put the link into the chat, our YouTube channel. So now, without further ado, I'd like to introduce today's speaker for the session, Claudio Lassala. He's a technical director at Improving. So Improving is a leading software development company that offers advanced technology consulting and training across our 14 locations through the North America. So Claudio has a wealth of experience, over 20 years in the IT industry, and he's going to share some of his experience today with our community. All right, so really excited to have Mr. Lassala here with us, and without any further ado, Claudio, why don't you go ahead and take it away from here?
Absolutely. Thanks, Hannah. Thanks for having me. The introduction. Let's switch over to my screen. Hello, everybody. Thanks for joining us. That's always appreciated. You know, you take a bite and you support the community by joining these meetings and contributing with your questions, or, you know, passing along the things that you hopefully learn from these meetings. That's always appreciated. I'm just moving some screens around here so that I can make sure that if you guys and gals have questions, you can use the chat window. Like Anat said, I will have a couple of spots where I'm gonna take a breather and specifically ask if anybody has the question. But if something comes up, you know, drop it in the chat. I'll keep an eye on it. If it is something that I feel like I can take it as it comes, I'll do it. Otherwise, I'll just save it for later when it's you know, it makes sense within the flow that I'm going through. So this session is all about refactoring test code, which I'm pretty sure most people who are joining this call here are familiar with test code, and I'm pretty positive that you know, folks will relate to the topic, and essentially pushing that beyond the Red-Green-Refactor mantra that we learn as we get into any level of automated testing that we get into. Quick information about myself so that you know who I am and how to find out more about me, or even reach out after we're done with the talk. You have my email up there on the screen, Claudio Lassala at improving.com. So if you have any questions or further comments that may come out, or, you know, if after this session you want to try some things on your own, you know, and you run into some roadblocks or some challenges, please feel free to reach out. Let me know what those are, because that helps me also keep improving how I do these things. I'm a technical director here with Improving in our Houston office. I do a whole bunch of stuff besides software development. You're going to be hearing me talk for almost a full hour about my technical background and the things that I do. But as you can see on the screen, I also do some other things. I try to live a full life with hobbies and a lot of exciting things, as you can see. And been doing software for over almost like 25 years or something like that now. It's an area of passion of mine. As a developer, and that's been like about 25 years. And then you might say, well, but this is a QA type of group. What are you doing here? Well, a huge part of what I do has been around testing as well. So I've learned about you know, automated testing many years ago, and ever since I've been incorporating that into my work, the way I actually do software development. I have a whole session on how I've moved my thinking about testing, where it used to be an afterthought, right? I would write code, I would build things, and then afterward, I would write tests for it, automated tests for it. I've since switched that around where it's just an integral part of how I do work, right? And I have a whole talk you can find in our improving channel on YouTube. There's the talk that you can easily find. But beyond that, I've been focusing on like coaching people on test-driven development, behavior-driven development, end-to-end testing, and all these things. And something that we always hear people talk, and we get into it ourselves, is the whole red-green-refactor, right? Where red, you write a failing test, and then green, you write just enough code to make that test pass, and then you refactor. The size of the boxes here is very intentional. This is where, like, the size of the box should be, in my view, where we spend most of the time, right? We should spend a decent amount of time in that red part, making sure that we are writing a meaningful test, and then we write just enough code to make that test pass. And then we should be spending quite a bit of time refactoring, not just the implementation code, but also the test code, right? Many times I even start refactoring my test code first, and then I refactor my implementation code. Why do I make such a big deal about it? Well, the test should document the feature that I'm building. So it should read just as good, if not better, than the implementation code, the code that's going to get into production. And we're going to be revisiting this model later on in the talk. The talk's not specific to any programming language, even though I'm going to be showing most of the examples in C#. There are some in TypeScript/JavaScript, but I've really learned this process many years ago, and I've applied in many different languages. So the language really does not matter. It's about the approach. So whether I'm writing Ruby, C#, JavaScript, TypeScript, I'm following always the same approach. So because we all understand the domain of pizza, I guess everybody eats pizza. So that's what this initial sample is going to be about. Let's pretend that we have some code somewhere that knows how to make meat lover pizza, right? So you're going to create a pizza, you're going to add toppings to it, you're going to return that. One way, or the day one of writing automated tests, we learn about the arrange, act, assert template, right? Where arrange, you put together the bits and pieces of the thing that you're going to be testing, the system under test, and then you're going to act on something, right? You're going to fire that or trigger that action. And then after that, you're going to assert on the results, right? To make sure, hey, after that action has been performed, this is the outcome. It could be an interaction with other services. It could be the state of something that got changed, right? And then we have assert, like in this case, contains pizza toppings, and then the different types of toppings. That's how we learn in day one. What I've learned in the last 15 years or so is that the thing that we learn in day one, we end up going 10 years doing exactly the same thing, which is not a good thing, right? That's not signs of, evolving our practice. So one of the main problems with going back to this slide here is that when we have a suite of tests where a bunch of tests look like this, rest assured that this code will get copied. As soon as somebody has a new requirement, maybe now we need to make a Hawaiian pizza or a Supreme pizza. Guess what? We're gonna go in, look for the tests around that feature. We're gonna find the one that looks the closest to what we are gonna be creating next. We're gonna copy and we're gonna paste it, right? And it takes no time for you to end up with a test fixture, one file that has thousands of lines of code and they all look very similar. Like the setup, in this case, the setup, the arrange part is very small. Of course, it's a contrived example. In the real world, you're going to have tens of lines of code. I've seen hundreds of lines of code just in the setup, setting up mocks, setting up your objects, and then you act, and then you have dozens of lines of code, sometimes hundreds of lines of code with assertions that get copied, right? In no time, people will abandon those tests. Why? Because it's too hard to maintain and understand those tests. Because the practice is, when you have a new requirement, when you have a defect or a bug, what do? You write a test first, and then you do the implementation. Sometimes the implementation, all it takes is like an if block that you have to add somewhere. You look at the tests, like, well, it's going to take me 100 lines of code to test this one if block. And I don't even know which 100 lines of code I should be copying and changing. So I'm not doing the test. And then over time, the tests get abandoned. So it defeats the purpose of having them to begin with, right? So that's a problem. That's why I raise it as a big point there in the talk. So a very easy little improvement that we could apply to that initial test was to rewrite it like this. Assert pizza only contains the following toppings. And what are the toppings? How's that different? Well, in that format, we're not exposing all of these mechanics here. Like, oh, we are using the assertion here, the assert contains to verify that. We are looking specifically about a property inside of that object. So we are looking very closely at the implementation, how that feature is actually implemented. Is that really what we want to do? We are, in this case, specifically looking for the name of a topping. What if we had a different way to reach into the name of that topping instead of having a name property? So we are going pretty down close to the actual implementation of the feature. Whereas on this next one is like, I don't really care whether topping is going to have a name as a string or whether it's going to be a value type representation of that may be something else. I don't care about any of that. I'm just trying to use this test to describe the ideal outcome that I have, right? So that's already a very simple improvement that everybody can make. Better yet, look how I changed the name of that little method that does the assertion, right? So previously, I was following the C# guidelines for naming methods, because this is how methods are normally named in C#. Now, I banned that rule by following this, and then some people will say, oh, that looks like Ruby. Well, yeah, that's where I actually got that from. And I will shamelessly apply this convention. Why? Because even though, yes, we are looking at C# code, the intention here is not to create code that developers are going to be, instantiating these classes and calling these methods in the production implementation. No, the intent of this code is to describe features. So I will bend C# or whichever language, as I'm going to show next. I'm going to bend those languages to my intention, so that when I'm showing this to somebody, if I'm sharing this with a business person, for example, or somebody who's non-technical, they're not going to say, oh, you're in C#, but this looks like Ruby. They're not going to say that, but they're going to say, oh yeah, assert pizza only contains the following toppings. Okay, I can actually read that, right? So non-technical people can read your expectation, which is a big win-win in my book. Now, that wall of characters, remember, coming back here, we have what I normally call a wall of repeated characters, right? Because you have assert contains pizza toppings, topping, topping. How many times do you have to say topping in the same line? And then you copy that, you have that wall of characters where the only part that changes is towards the end, like the last fifth of that block. Well, by doing this, we completely removed that wall of characters. We don't have to read through those characters to see, okay, how do they vary? We don't need to do that, right? And the way to do it, it's like, you probably guessed it, right? That method simply takes in the object, it takes in the expected toppings, and I just for each through that list and do my assertion here. So if later I want to change the way I do my assertions, if I want to build a more developer-friendly assertion message in case something goes bad, I have one place to change that, as opposed to go through hundreds, thousands of assertions in my code base to address that, right? And then, like in this case, what if somebody throws a pineapple in that meat lover pizza? Oh my goodness, right? I like my pineapple in some pizza, but not in my meat lover pizza, right? That's just me. That original test would not catch that, right? Because that original test is only checking to make sure that, hey, does that pizza have the following toppings? Okay, but what if there are other toppings there that maybe I'm allergic to? Those tests will not catch that. If somebody makes that change to that code, nobody's gonna see a pizza coming up with a topping that was not requested. By isolating that into a separate method, then you could come in and say, oh yeah, let's change the way we are asserting on the topping verification of pizzas. And besides that little for each, let's also maybe look on the count. Hey, does the count of toppings match the expected? Anything above or below, there's something wrong. And then you can, of course, improve the assertion message in case it fails to give something meaningful, to not just report, hey, we expected 5 and we got 6. Okay, 5 and 6 of what? Maybe you want to explain a little more. Hey, we got more toppings than we asked for, right? So we get something like this. At least we get something like this in case of a failure, right? Not extremely helpful, but better than not catching the issue at all. Following from that, the next point that I would like to make is get to know your assertion library. We all learn to use assert equal, assert contains, and we just get stuck with that. We don't explore the assertion libraries that every testing framework definitely has available to you. So like in this case, what I've learned was that, oh, hey, look, instead of doing that for each the way I was doing before, this test framework that I'm using here, if I give it 2 arrays, it will do that for each for me, and it will tell me how it differs, right? So I just cleaned up my assertions even further. I removed the for block. Now I'm using just, in C# link selections, turning that into an array or projecting that into an array and just comparing the two. That's even better, right? When the test fails in this case, at least we get a little bit more. Hey, we expected an array with the following elements, but this is what we got. Well, it is a little bit better, but it's like, okay, it's truncating the response. So I don't know what else I got here. I'm not seeing that pineapple that showed up. So if you're dealing with small arrays, this may just be okay for you. If you're dealing with bigger arrays, then again, you have to think, how do I want to report those violations or those assertion failures, right? So get to know about your libraries, because they all allow you to extend the assertions into something more meaningful to your business domain. So as we have it now, can we make this better, right? As it is, okay, it reads all right. It doesn't have duplication. It doesn't have the wall of characters, but how can we make it better? Well, see those ugly looking comments? That's how I set up my IDEs to show comments with, yellow fonts on bright red background so that they draw my attention. So it's a very common practice to do the arrange, act, assert as little comments like that. But that to me, it's still very technical. I would rather get rid of those and reframe the way I use those words in that template. So instead of thinking of arrange, act, assert, how about thinking in terms of gherkin, right? Or given, when, then, because really a range is a given. Given the following context, given the following state of the world, act is the when. When this happens, right? Then, right, assert, then, now why do I make a big fuss about it? Arrange, act, assert, it's very technical. It's how we developers, QA, folks learn about this. Business folks, they don't quite relate to that. It's not exactly how they talk. But if we flip that around and we talk in terms of given, when, then, okay, that makes a little more sense in English at least. So from there, what would I do? I would turn all of my AAA, arrange, act, assert, into given, when, thens. I would take that another step, which is usually those givens, those arrange, the setup of our tests, they look very similar. How about we acknowledge the similarities and we abstract that into a given method, right? In this case, given a pizza maker, and push that someplace else. Now, instead of reading var pizza maker equals new pizza maker, parentheses, yada, 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 we just read given a pizza maker, right? Once we have that in, we should test at every step. So as I go refactoring test, I make like 1 line, 2 lines cleaner, better. I run my tests. Because sometimes even the simplest change where you think, I'm not breaking anything. Sometimes you are. Maybe you are not the one who originally set up the tests and you're overlooking something important that, it's not apparent. If you go and you make too many steps refactoring code and you don't run the test, and then when you do run the test, it's now not passing, how do you know which change you've made that broke the test? So little change, run the test, little change, run the test. Got everything working. Now guess what? I can reuse in the other tests that I have for that feature, that same given a whatever, right? And as we start typing, IntelliSense kicks in and say, given. Okay, given what? We may have like a series of givens that we can reuse within our test cases, which is very convenient and helpful. When I share this with people, many times C# devs, at least they say, hey, we're sharing, the tests are sharing a field. Isn't that bad, right? Because now the given a pizza maker creates that pizza maker into a field that's shared within all the tests within that class. I don't really care because I have it set where the tests within the same file, they do not run in parallel. Right? Whenever the test runner picks up those tests, it will run one test at a time. So tests in different files, they run concurrently, no big deal. Within the same file, it's one at a time. You might say, well, if I have, 100 tests in that file, then I have to wait for each one to, like, no, you shouldn't have 100 tests in that file. I have a whole separate talk where I talk about context-based testing, which I'm totally okay with, offering for this group as well, which is a good continuation to the talk that we're giving here. But the main thing you should take out of this is that I favor test files that have 1 or 2 tests, very small cases, and they run real quick. So the fact that they're not running in parallel, it doesn't change anything in a huge suite of tests that I have. With that out of the way, we can move on to the when part, right? So now we already have given a pizza maker in all tests for that feature. I can do the same about the when part. Let's extract that into a separate method, right? To improve the readability there. Given a pizza maker, when making meat lover pizza, we can also use casing to improve readability, right? Because we're going to have different when making this kind of pizza, when making that kind of pizza. So I like making all uppercase the things that make this when different from the other ones, right? So that when we are reading through the test, it screams at us. It's very easy to identify what kind of pizza are we testing here? Well, it says right there, meat lover. It's screaming and yelling. Our brain will see that before it sees everything else, right? So easier to pick up what are we verifying here. As I'm creating those, the GWT, the given when then methods, I tend to push them all the way to the bottom, because when I open test files, I want to see those given when thens at the top. That's the first thing I want to see. I want to see English, right? Because that's how I think. That's how I communicate with other people. I don't talk about, you know, instantiating variables, calling equal and new and parentheses. We don't talk like that. Developers do want to talk like that, but when we're talking with the people we are building software for, they don't talk in those manners. They talk in English, they think in English, and so should we. So that's why my test at the top, I want to see given when thens. Everything else, I'll just push it to the bottom of the file, sometimes in separate files when I want to reuse some of those things. Is that good enough? Right now, this test already looks pretty clean, but that assertion still says assert pizza only contains the following toppings. I would still take that one step further and say, you know, when we do TDD, where we say we do test-driven development or test-driven design to define what is the code, the shape of the code, the API that we would like to end up with. I approach testing or test code in the same manner. When I look back at this, like, assert pizza only contains yada, yada, yada. Is that how I want to read that test? How else would I want to read that? Well, I like this better. Given a pizza maker, when meat lover pizza is made, then only the following toppings are expected in a list of those toppings, right? Notice that I got rid of the, you know, passing in the underscore pizza, passing in an array of strings like that. Got rid of that, right? So I can see that. Now the business is growing, right? And so is your understanding of BDD and TDD. Let's say that somebody, now the business owner says, I want to make a Brazilian pizza. By the way, I pick on Brazilians because that's where I'm originally from, right? So I'm entitled to pick on Brazilians. And the business owner says, hey, now we are making a Brazilian pizza. Oh, a Brazilian pizza? The heck is that? I've never heard of that. Right, so let's talk about it. Let's get some acceptance criteria on what a Brazilian pizza would look like. And in this case, the owner says, then only the following toppings are expected. A lot of meat and cheese. That's how he described the feature to me, right? So this is behavior-driven development. We're thinking about the behavior of the feature. From there, we jump into test-driven design, TDD. Right, so it's like, given this behavior that we want from the business, this is what I'm thinking the code should look like, right? Notice that my IDE will show things in red because I don't have those elements yet. The pizza maker does not have a make Brazilian pizza. It does not know anything about special requests that these Brazilians ask for. This is something that in conversation, we're going that route, but I'm making up my mind. I don't know yet if we are still going to use the make Brazilian pizza method on the pizza maker, or maybe we're going to have a different method on a different class altogether. I don't know. Well, but aren't these the tests for the pizza maker? No, they are the tests for making pizza. The fact that we have a pizza maker class, it's not as important as the feature itself. So detach your idea that, oh, I'm testing this class. No. You're testing a feature, right? There's something bigger. There's a bigger context behind that implementation. So this is where I draw the line between BDD and TDD, right? It happens in the same file, but it's good to understand this separation. And now we're talking, right? We're talking with people. Because when we have tests like the ones on the left, yeah, a lot of developers should understand what's going on there, right? But it shows a lot of mechanics. It doesn't really talk about business features and the business language. And I wouldn't feel comfortable showing that to a stakeholder, to a product owner, to a non-technical person, because they would have a lot of mental parsing going on with the topping equals or greater than topping name. That's how they would read that, right? There's a lot of mental parsing into those things. That would not be helpful. It would not encourage conversation and collaboration with other people. The tests on the right, on the other hand, yeah, I do it all the time. I share that with non-technical people. They see it along as like, oh, there are some curly braces that I didn't expect. There are semicolons that, but yeah, the green part where we see English, right, and the orange where we see like the outcome of those things, they can read, you know, along, and we can have conversations, even though they're not C# or JavaScript or Java developers. Huge win, right? And when we do that, look, no libraries. We're not using, like in this case, SpecFlow or Cucumber or whatever, because many times when I'm talking to people about BDD, they're like, oh, that's all great. I need to set up my CI/CD pipeline, and what tool should I use? Should I use Cucumber? Should I use SpecFlow? Stop. Use a napkin and a pen. If you can write down features in given when then sentences, then you're good. If you can't, there's no tool that's going to help you. Yeah, you can create those tools that you point at an application and it's going to spit out some given when thens for you, but that's a tool doing that. The tool does not know the intentions, right? So it only takes you so far. So this is like lowering the barrier, the entry barrier into BDD. That's why I like this approach. Again, it's just plain old C# in this case, right? It could be Java, it could be JavaScript, and I'm not doing anything special. I'm still just using some methods. The only thing difference is that instead of using the C# naming convention for methods, I'm bending the rules, because in tests, the intention is I want to encourage conversation with people to make sure that we are actually building what's meaningful to the business, right? And people appreciate that, right? You don't have a hard time selling automated tests to non-technical people when you follow this kind of approach, because you're using their language. You're putting their interest before the technical aspects of things. So it's a huge benefit that we get out of that. The business will thank you. Believe me, I've been harvesting a lot of benefit from that. This is a good a spot for us to pause and see if there are any questions. Please drop it in the chat window. And I still have some other goodies to show here. Meanwhile, let me take a sip. Hopefully you are either typing or everything is good. If you're typing, I'm going to give you another minute or so. There is also in the improving YouTube channel, which was posted in the chat window. Thanks, Kanat, for that. There's also a talk of mine called Trusting IT, Bridging the Gap Between Vision and Execution. I would encourage you to check that talk out as well, because I talk a lot about, how do we build trust between the delivery team, developers, QA, UX folks, and the business, right? The stakeholders, the product owners. And in that talk, I go through like the importance of good tests, the way we write tests, the way we write user stories, the way we have conversations around those assets. So make sure to check it out. I'll keep on rolling. I don't see any question coming up. If they do, I'll take them as we go. Where's the love for JavaScript and TypeScript, right? Because everything we saw so far, it's a C#, but as I said, that's plain vanilla C#, nothing special about it. And I follow exactly the same mindset and approach when I'm writing tests in other languages. So for example, what you're seeing here is this is TypeScript. It could be JavaScript as well. For tests, these are tests for Angular components, okay? Now, look at the wall of characters. there that I've mentioned before in that C# example, right? Where you see expect result has on property, some property, to be false, to be false, to be false, to be false. Okay, expect has on property, da da da. Oh, down, you know, there you see there's something changes, like the pattern of those lines changes, which makes you read closer to see, okay, what's different here? Oh, instead of result, it is result.sales order header, da da da, to be true, as opposed to the to be false in the other ones, right? So these little nuances, I look at it and I think, okay, how else would I want to read this code, this test, to make it easier for me to understand what's going on here? Which ones are true? Which ones are false? Where are we checking? Is it the result or a property hanging off of results? So I rewrote that thinking, I would like to write this test more in this manner. And then I came up with something like this. Expect result to have properties, draft ID, and sales order header. Expect results to lack properties or to not have properties, however we want to word that. And these are the properties that I expect not to have there. Expect result sales order header to have properties, the following properties, right? Still the same test as the one on the left, except that the one on the right, if I want to add a property to those verifications, I just add the property, as opposed to copy and pasting a line that reads expect result dot has on property, some property to be false, to be true, right? So it improves readability of the test, and I can reuse those extensions that I've added to my testing library. We can create better reporting, because like in that case, when I created that little extension to have properties, and I'll show you what that looks like, but when we report violations to those assertions, then we can say, hey, on that test, object is missing expected properties. This is what we received, customer address, and so on. And what are the properties missing? In this case, seller ID XXX is a property that's missing. And we see the line, so it's very easy to see, oh, we broke a test. Which test? That one. How? Well, it's missing a property. Which property? It's right there, right? Remember extending the assertion libraries. So whichever test framework you're using, make sure that you get familiar with how you create your own matchers that you use for assertions, because you're likely want to create custom matchers that are domain specific. For instance, in the if you're building a pizza making software, the guys who created Jest or Jasmine or Cypress, they know nothing about pizza toppings. That's a domain specific thing. They know about assertions. So create your own domain specific assertions using the library for the core assert are equal, assert contains, assert is true, is not true, but put domain language around those assertions. So in the case of a Jest, which is what I use here for Angular, you extend it by doing something like this. Expect extend to have properties is the thing that I've created, right? It's a custom matcher. At the top here, you just see it's plain old, go through a list of properties and just compare and figure out what's missing. And then at the bottom, all you have to do is to make sure that you return the message that you want displayed in case that assertion fails, and whether, the logic is passing or failing. That's, as easy as it gets in a Jest to extend its assertion library. So this is, borrowing from another test for an Angular component. Notice the given when then, right? So now we are in TypeScript testing Angular components. You are still going to find given when then. You don't see the assertions right here. You don't see the setup right here. The acceptance criteria is something that we created here, and we've renamed that to scenario to go more with, Gherkin and BDD. So instead of thinking acceptance criteria, we're thinking about the scenario that we are testing, right? Now, what about, for instance, Cypress, right? So my team here has been using Cypress IO to do end-to-end tests. And months ago, I had to write a test where I want to verify the text on a certain element on the screen. And then the way I've learned in Cypress, at least back then, was to go cy get what is the attribute that I'm looking for, that I'm going to be able to find that element, and then should div goes into this function, expect div text to include, and then the thing that I'm looking for. And then I thought, man, that's a lot of language to just verify that this guy here, the report target quantity, has fulfill 250. Too much language, right? Because then what happens is, if I need to verify other things, copy, paste, copy, paste, copy, paste, not fun. And then I thought, how would I like to read tests like that? And I came up with something like this, because I know that Cypress also has like a should have value, should have whatever. I said, well, can I do like a should have included text, this thing here, right? Because it's much easier to read the thing at the bottom than the thing at the top. And I don't have to remember all of that syntax to pull that off, right? So I said, how do I extend Cypress, its assertion library, to do the things that I want to see there? Remember assertion libraries, by now you do, right? So like in Cypress, I've learned that you can go, you know, it uses chai as the assertion library. You can add methods to it. So I included my included text. Well, but what about that have? Have is something that Cypress already offers. So you don't have to do anything, right? You just have to provide the thing that you want to make sure that it has. Included text, that's the syntax for it. Use the chai assertion to make sure that the element exists, pull the text out of it, what is expected, and then do the assertion as you would in the regular test, except that I'm wrapping that up in something that I can reuse to hide away all of the syntax that I honestly don't want to see when I'm reading through the test and trying to understand, okay, what's going on here? I don't want to see extra syntax to try to understand what's going on. So more Cypress, this was a slightly more complex test I had to write, where the feature was we're adding categories to the system, and it's a hierarchical tree. And I was validating that, hey, whenever the user is typing something in two fields, there is a code and a name. In this case, the user was typing code meat, and then the name delicious meat. And it's a table, right, with many rows, or it's a list with many rows. And I needed to go get the rows with categories. Within that, figure out, okay, what is the ID for each row? Because the one I just added, my new row ID, that's the one I want to grab. And then I want to verify the name and the code to make sure that it is what I tried to put in. Notice that here I'm already reusing that extension I just showed in the previous slide. And then I need to parse that ID out of the thing that I found out. And then another thing that I want to verify is that not only do I see that on the screen, but an API call gets made with the following expected values, right? So test works great. I see myself creating more tests that look exactly like that. And I'm like, there's too much syntax here. There's too much stuff for me to remember the next time that I'm going to write very similar tests. And I don't want to be copying, pasting this kind of code. How else could I write that? This is what I came up with. Visit the thing, right? The one of the rows, row one. That's going to give me the ID to that row. And then I want to verify that the category is meat and delicious meat. And I want to verify that the add API call was called with the following parameters, right? It's much more declarative as what we are doing, as opposed to being imperative, meaning it's actually doing the thing. The code on the left actually does the thing. The code on the right tells us what we want out of it, but not how it's done. The how it's done, it's hidden away someplace that I can reuse. And if I want to read, I want to see how that works, I can always go into that function and figure out what it's actually doing. From the outside, when I open that Cypress test, look at that. I see given when thens, right? I see English, even though I'm in TypeScript, and those functions, they're at the bottom of the file, right? It's not like, oh, it's hidden away, nobody knows how that works. Well, just keep reading, right? But when I open this test, if my business friend says, hey, we're having problems adding categories to the items in the catalog. Okay, hold on. Let me pull up the test, which tells us our assumptions. It tells us the scenario, the acceptance criteria that we've agreed on, and this is how it's described. So I can show that to the person can read it just fine. We can have a conversation, collaboration, and then take it from there. Works great, people love it. Same language, English, better communication, right? You see the examples on this slide, they are tests on the far left, unit and integration tests for backend things, right? C#, Java, what have you. In the middle, we have unit tests, integration tests for the front end, your Angular, your React, your, however you're building your front ends. And on the far right, we have end-to-end tests, whether you're using SpecFlow, Cypress, it doesn't matter. Look at the description of the language looks exactly the same. Given when then, given when then, given when then. Nothing special. I'm not using special libraries, special nothing. Just the regular test frameworks for that, right? The syntax is slightly different because different languages and different test frameworks will be slightly different, but the core of it is the same across the board. And then when I give this talk, many people ask, or often people ask, well, what about Cucumber? What about SpecFlow, where you can just write those things in plain English? Wouldn't you use that instead? I have in the past. A lot of it I've learned from using Cucumber when I was doing a lot of Rails development like 12, 13 years ago. And that's where I picked up a lot of this. When I had teams or situations where people writing the given when thens were essentially non-technical and they were putting the effort into writing and maintaining those, yes, that worked great. But those were very few situations that I've run into. Most of the time, I've had developers leading the effort into writing better acceptance criteria in the shape of given when then. So instead of trying to maintain text files and then the step files and let the developers write however they feel more comfortable, for example, maybe writing just straight in C# code in a way that they can read. Yeah, there are some weird underscores or formatting in the way that it looks, but people can still read it. And it's the guy who's maintaining option to stick with something like that. So my main point here is think of your team, think of who's reading or who's writing those specs, who's implementing, and who's maintaining that. Because just writing that in a way to produce reports that nobody reads, what is the value, right? So we need to, I evaluate that on a case-by-case basis, based on who are involved in the team, who's actually doing the work, who is reading that information, and what are they doing with that information, okay? And last but not least, I saw one comment that come up, or one question that came up, and I'll be tackling that in just a moment. Actually, this is the perfect moment to take that. When did the team start refactoring? Was it while writing new tests, or there was a kind of stabilization sprint for refactoring? Outstanding question from Hala. I hope I got your name pronounced properly. So this is how I've learned and how a lot of people learn. Oh, we are writing automated tests now. We learn the mechanics of doing so. So it's like, oh, how do we automate the browser with Selenium, for example? And we learn, okay, this is the test framework. This is the test runner. This is how they work. This is how they produce output. This is how they automate the browser. So we are learning the mechanics. We're learning how to ride a bicycle. So you have the training wheels, right? And we do a lot of that. Over time, we start seeing that, oh, you're copy and pasting a lot of boilerplate code, a lot of code that's, when I open test code and I'm seeing too much boilerplate code, like, oh, this is a lot of Cypress code. This is a lot of Selenium code. This is a lot of Angular stuff that's necessary to run the test. And I see a lot of that and very little of the business scenario. That drives me insane. It's like all the mechanics is actually hiding what's really important about these tests. So at that point, I started learning how to refactor the tests to make it read where it highlights what's important from the business perspective of that, whatever it is that we are testing. So then I started learning, how can I refactor this in a way to make the test read better, right? So that came after many years of writing tests like that. At least that was my case. Nowadays, what I do is when I start a new team, instead of saying, okay, we are doing BDD all the way through, this is how we're doing it. I don't do that, right? Because if people on the team are already familiar with the concept and the techniques and the process and the practice, then yes, great. But that's not usually the case. What I normally do is, okay, let me understand where the individual team members are in their journey, and I'll just tell them, you know, if you know how to write tests, go for it. Do it however you know. If they don't, then I'm going to start at the minimal level. It's like, okay, let's talk about test runners, test frameworks. This is how you write some basic tests, and let them get experienced with those. If they are already writing tests for many years, but it's a lot of arrange, act, assert, a lot of copy and paste, then I'm going to help them take the next step. Okay, let's pick one test. Don't try to refactor all of them, right? Pick like the most important ones. Like, okay, these features, they are the one making or saving money for the company. Let's start with that. Okay, since they cover such an important feature, how can we make it better? Take the first step into refactoring. Maybe clean up some of those assertions. Great. Now let's clean up some of those arrange part of things, right? Got a bunch of those going. You got into that mindset of, okay, how do I refactor it? How do I refactor it? The more refactoring you do, the better it's gonna enable you for the next time you write tests. Because now you're gonna go like, well, if I write it in the old way, I know that when I refactor, I'm gonna end up with something like this. You keep doing that, you're gonna start your tests from that perspective. And then you keep doing that, you're gonna start seeing better ways to take that a step further, right? But you definitely, it never worked for me, like pushing onto people and say, this is how you're gonna do it. You don't get adoption, you don't get buy-in from people. People are not gonna get encouraged or inspired to do their work in that manner. So it's a lost cause. Work with folks, see where they are, and then figure out, how do I help that person take the next step, right? And then move on to the next team member and the next team member. And that's one of the ways to go about it. Of course, different organizations, different teams, it takes different skills to get the practice going. Should we refactor the code in a separate branch? If yes, how would this sync the refactoring code with dev branch? It really varies. Thanks, Yusuf, for the question. It varies. Hopefully, when you refactor the test, you're not breaking it, right? You're just trying to make it better. When I run into a situation like this, it's like, okay, I'm reading this test here, and I believe I can make it more readable, right? Easier to understand if I do the following. Usually, I'll cut a different branch. I will apply my changes. Okay, let me try this, let me try that. Sometimes I take 3 or 4 steps. I think it looks cleaner, but then I compare to the original ones, like, that's not a whole lot better. Scratch it, start over. When I get to something that I'm like, okay, I think this is, better, at least for me now, let me run it by the team. Like request a code review from somebody else on the team and say, hey, what do you think of this change here? Right? Does it make sense to you the way it does to me? That person might say, heck yeah, that's way better. Or, what do you mean by that? Have that conversation. Try to find something. Maybe it's the language, the way you're conveying the thoughts through code in the test. Validate that with the team, right? Get more people involved. Once you get to a point where it's like, yep, the tests are still passing. I didn't break anything. I didn't change the implementation, of course, because I'm just changing the test. I've cleared I've verified my assumptions about what makes it more readable with somebody else on the team. I'm good, merge it, right? And hopefully, again, you make more people on the team aware of those changes, and not just how you did it, but why you did it. What motivated you into doing so, right? And again, if you run it by more people, you get more people involved, more people committed, more people willing to make those changes, right? Hope that makes sense. What other questions? Please go ahead and keep using the chat window. Just as we wrap things up here, what did we learn? Refactor tests make refactoring implementation code easier. That's a point that I make because we say one of the benefits of having automated tests is that it makes refactoring easier. Let's go back to the original definition of refactoring, right? We apply or we do refactoring when we want to change the internal implementation of a feature without changing the external behavior. If in order to do that, you have to change your test, then that test is not really helping you refactor things. And by test, I mean where you describe your test, your given when then. When we have the arrange act assert, like in the pizza toppings, we decided, oh, we want to change the way we have toppings on a pizza. Well, we're going to have to change the description of that test. Not great. If you have your given when thens in English like that, right, and you want to change the implementation, the internal implementation, it shouldn't change the external behavior that's the desired behavior, right? Going with this approach, it actually enables you to change the internal implementation without changing the external behavior, the behavior that has been agreed upon based on the user stories, the acceptance criteria, the conversation with the business, and all of that. So you feel safer refactoring your code if you have tests that will really, cover the bases as far as like, yeah, the test describes what we actually needed and why we need out of the system. Red, so we spent quite a bit of time thinking, how am I going to be testing this? What is the feature that we are really building here? What is the context? What are the actions? What is the outcome? Once you figure that part out, and you have a decent test to start, implement just, as little as you can to make it pass. And then you should probably spend most of your time refactoring the test. Hey, does the test actually really describe what's important here, right? Why we're doing certain things, not how, but why. Once your test looks like, yep, this totally describes what we're building here. Okay, now refactor the implementation code. Along those steps, review it with other team members. Say, hey, this feature here, the tests are passing right now. The code is not the final production level yet, but let's look at the test. This is a test that I came up with. Does it make sense to you, right? If it doesn't, have that conversation. Streamline the language that you use, the English language that you use describing those tests. And then it's like, okay, this is good. Now let's look at the implementation code. Now make sure that the implementation code is also sound, right? You are using your nouns, your verbs as it comes from your business language, and it's moving all the way into the actual implementation code. So please go ahead, drop in some more questions if you do. Remember, that's my contact information if you want to reach out and ask further questions or clarifications. Check out on the Improving websites. We have a thoughts page. I have posted a blog post about context context-based testing, which is like a high-level overview of what the next step would be after you've done this kind of refactoring. And then again, I have a whole talk just about context-based testing. Make sure to check out, I have a virtual brown bag meeting, which is a weekly meeting where I'm always sharing stuff that I'm up to. Check that out. At Improving, we have some free lunch and learns that happen every Friday. You have the link here to check out. We always have good content coming up. We have training classes on a lot of these topics. And we're also hiring. We're always hiring good people, good talent. So if you're into, software development at any shape or form, as a QA person, as a developer, a consultant, an agile coach, whatever the case might be, reach out. Let's have a conversation and take it from there.
All right. That's such a great presentation, Claudio. Thank you so much.
Thank you.
For the record, I've never tried Brazilian pizza, so I think it's time to try Brazilian pizza as well.
A lot of meat.
Oh yeah. So we are pretty much at our time, guys. So unfortunately, that's all the time we have today for this session. And thank you again, Mr. Lassala, for your time and expertise. And on behalf of our Houston Software Quality Engineering Group and our presenter, I would like to thank everyone for joining us. And I wish you good, enjoy the rest of your day. Thanks again. Appreciate it.
Thanks, you too.
Thanks, Claudio.